This is a quick kind of crash course in writing a user driver for Android things. My name is Tyler Williams. I'm a developer at Tubles. I do mostly Android stuff. I'm not really a hardware guy. I'm mostly an Android guy, but I thought I would step into this to kind of learn the new platform and play with it a little bit and just share my experience with you guys. I just wanted to get a feel for the room. Like, are there hardware people in here? Does anybody have experience doing this kind of stuff on maybe more traditional platforms? Nobody? No embedded systems engineers, anything like that? Cool. Well, we're in good company then. So to get started, I did my development on the Intel Edison SparkFun breakout boards. If you want to look at it, it looks like this. Takes a second. It's a 32-bit processor, SOM, which is an acronym for System on Module. If any of you guys were in Dave Smith's talk yesterday, he kind of went over some of the points on this. It's got Bluetooth, Wi-Fi, a gig of RAM, all built into the chip, which is pretty cool. And then, so this, oh, I'm not on my slides anymore. So yeah, this is the chip. These are the two breakout boards I'm using. One is a base board. I like the SparkFun stuff. I guess it's kind of defunct now because Intel's not making the Edison board anymore. But there's still a few out there in the wild if you want to get your hands on them. They have this really nice, super small form factor you guys can see. So if you want to prototype something kind of small, it's pretty easy to do. Yeah, so the baseboard comes with that the serial bus on it that attaches to the chip, and then two USB ports, just like developing on an Android phone. It gives you access to the console on the chip, and does things like power the other boards, things like that. And then the I2C breakout board is on top of is attached underneath that. I2C, for those of you who don't know, is a serial hardware protocol for interfacing with peripherals, which I am using to interface with this accelerometer, the MMA 8452Q, aptly named, wonderful. I picked this one because I couldn't find a driver for it for Android things right now. So we can write one. Yeah, so the things that you need to do this kind of integration are pretty straightforward. The documentation in the hardware world is what they call a data sheet. It comes with all kinds of handy information, power, things like that. For example, this is a 3.5 volt maximum chip. USB naturally is at 5 volts. So if you were to plug this straight into like a USB powered device that didn't have some sort of like step down on it, you'd fry your sensor. So these are the kinds of considerations you need. This board naturally steps down to 3.5 or steps down to 3.5 on its own. So we don't have to take those kinds of considerations. We don't need resistors or anything like that to protect our sensors. Yeah, so it provides a lot of this data. It seems kind of dense. I was really scared of it at first. But once you kind of get into working with it, it's not so bad. Useful things to note, that it's I2C, that it has a 12-bit and 8-bit digital output, which is your information resolution. Peripherals, hardware like this transfer data over a serialized register on I2C. So in that tells you how many of those bits you need to read to get the readings you want. and it's configurable between 12 and 8. Yeah. The next little bit there is just the different addresses of the different registers on the chip. Again, it seems kind of awkward to get used to work with if you guys aren't used to doing this kind of stuff. I certainly wasn't when I started this project. But really, the Android API is good enough that it's pretty easy to step into and do on your own. So yeah, let's look at some of the code. Actually, the first file that I want to look at is here. This is the driver I wrote. I borrowed liberally from some examples that were already up of other drivers. I think it's a good way to learn how to do something if you're trying to prototype a piece of hardware for work or for a project you have. There's a lot of good code that Google has out there for similar sensors, things like that. So you can kind of use it to map like what you're going to do moving forward. It's pretty simple to set up. All of this kind of information that you use to configure your sensor come from that data sheet. So you learn you can look up things like, for example, the power is just something I defined here. Right. So the max power is listed on the datasheet at 165 milliamps, and then it's pretty easy to do the conversion from milliamp to microamp, which is what the API asks for. It asks for the power reading in microamps. So you just you read your APIs, you do some pretty simple conversions, multiplication, and you put in these values, and that'll kind of get you rolling in just teaching Android how to recognize the device. So once you get that set up, it's pretty easy to do things like this. So you can set up the driver here, just using the readings you get from your data sheet, and then you can use the APIs that you're used to from interacting with Android sensors normally. Your peripheral manager, your sensor manager. I actually don't use this instance of peripheral manager. It's left in there because I'm sloppy. But you register it just like you would any other sensor on a device. You create your you get your service here of your manager, and then you register a couple of small details. So I create this instance of accelerometer driver here. That address is defined by, or that bus name is defined by Android. It's just pointing at the I2C bus. So you can do that. You just put that in. It's always going to be that value for I2C. Once we're here, it's pretty straightforward to take your sensor readings and do kind of anything you want with them. So you can, right now I was having trouble getting this on the network. But you can imagine once you have the chip reading, you can do whatever you like with your accelerometer data. Accelerometers could be used for any number of creative purposes, good rotational data, things like that. You interact with the Android Things board just like you do any other Android device. So you have all the tools you're used to using, ADB, the shell, starting things with intents, stuff like that, all works just the same, which is it's a really nice transition for someone like me who is trying to prototype things for work or for fun. And maybe doesn't want to learn like Yocto Linux or something like that. So once the boot process is done, then we can start to see. Now that we have the app running on the board, that we're translating rotational data across the. We're printing it to console, so you could do anything. I had an instance of retrofit in here, so I could just send some data model over HTTP if I want to. It's probably not like your best choice ever for doing IoT interactions over the network, but it's just as a demonstration. It's a pretty straightforward way to do things. That's again one of the big benefits of this platform, that you can use the tools that you're used to using. So yeah, though I have been kind of babbling here, it is pretty easy to penetrate stuff once you get your head around maybe working with like bitmath and stuff, which a lot of people stop doing their freshman year of college. But you can get your head back into it. You get to do things like work with it in Kotlin. Maybe not the best choice ever for like bit manipulation, but if you're just trying to prototype on a small board before get something rapidly off the ground, I think working in environments that you're used to is very valuable. So this is where we do the register reading, which is what the values I was putting to the console. To talk about the bitmath a little bit, you take the memory address from the data sheet. The data sheet tells us that our data starts at what they call the outx most significant bit, and then is in all of the consecutive the 5 consecutive registers after that. So you have all your X, Y, and Z data there. So I cheat a little bit. I read all 6 of those bytes into one array, and then pair them up into three floats, because the sensor API asks for a float array when you're for data. You just take the bits, you take your 2 bytes, you put them together. We had 12 bits of resolution, which we saw from the data sheet earlier, so you're at your 16th bit, you shift over 4 and you're your 12th bit, and now you're reading your data. Cast that to a float, and then stick it into your float array and pass it on down the line. And then you're reading it off of and then you're reading it in your activity here. So you define some listener like you would any other listener for any sort of asynchronous response. You get your values that you just passed. This is where I'm printing them. And yeah, and then, so this is kind of my little, this is my little, like, hacky retrofit implementation just to show it kind of like passing forward. If I was on network, we could define some data model and then pass it up. But yeah, that was my experience quickly writing a driver for a piece of hardware that I had never seen before with a little experience, and I found it to be pretty pleasant and a pretty easy process to negotiate. Definitely not as maybe scary as it seems if you're not used to doing that kind of stuff. So yeah, I'm a bit early, but that's kind of all I've got. If you guys have any questions about the process or anything.
Do you mind showing us the breadboard and how it's set up?
Yeah, absolutely. So the breadboard, does anybody here have any experience doing breadboarding stuff from school or whatever? Yeah, a little bit. Arduino stuff, yeah. So this setup I chose because I didn't want to deal with like power stepping, things like that. I was scared of blowing up hardware. But the basics of it are your IC2 setup has 4 major lines. The 2 that really matter are your shared clock, which is this SCL right here. I don't know if you guys can read that or not. The IC2 protocol shares a clock between a master and a slave. The Edison is our master. The accelerometer or any other sensor or set of sensors would be our slaves. And so the Edison defines a time signature, a rate at which data is transmitted. It is transmitted over this SDA line, which is our blue wire here. And it's just a one-to-one mapping, shared clock to shared clock, data to data, and then we have our 3.5 volt power and our ground wire here. Yeah, so it's IC2 is Android things abstracts away the implementation details of the protocol, so that you don't have to deal with like sending a start signal and sending a stop signal. You do have to do things like set. This is something I didn't show you guys. Let me find it really fast. Set standby and active modes. You do that by interacting with a single bit on the board. If you want to write to most of the registers rather than read, you need to tell the board to start listening for stuff. You do that by putting it in standby mode, which is a pretty simple. So we write some config stuff here, and standby just writes a byte of zero with all zeros to this register here. This the control register. So that puts it in standby. Then you switch it up to 1 to have it start sending data the other way again. Anybody else have any questions? Want to see anything? I'll hand it to him.
So you were writing a driver for this one because there wasn't a driver available. If I was using something that had a driver available, like what is the process like?
So Google has, in my experience researching this stuff, there are a number of contributed drivers in an repository, an Android Things repository on GitHub. Like any other library or something that you would compile, you just throw it in your Gradle. That's how those are. Maybe you'll have to add something with the NDK, something like compile something into your code. It depends on how you would consume it, how it's available to you. But yeah, the ones on the Android things like contrib drivers get, they have Gradle URLs for them.
This is more of a general question for like how to start off on Android things.
Yeah.
Like I have a use case in mind. I want a small button that I can put on my like AC and then connect it to an Android app so I can just switch it on and off from the door instead of having to walk all the way to the AC, right?
Sure.
So this is just like an example use case, but I don't know where to start off. Like where do I start off on figuring out if this is something I can accomplish using the Android Things API? How do I find out what kind of switch I need to figure out? Like, what is that process to get to where I can then start doing this stuff?
Yeah.
Does that make sense?
Sure, absolutely. And I think anybody who like does projects understands that anxiety, right, of like not knowing where to start. With where I start when I'm learning something new is I just pick a very small toy like this, and I just build it. For your example, the kinds of research you would want to do are so the first step is like, how are you interfacing with your AC? Are you going to have to hack into your thermostat on your wall and send signals that way? So those are the kinds of questions that you would have to start digging into, like the documentation for your thermostat, learning how it interfaces with whatever its microcontroller is. And then you're going to have to, but once you kind of learn that information, which there is documentation out there for, and it is learnable, you just have to be willing to kind of read some dense stuff like those data sheets. Then it's just a matter of just kind of buying some wires, getting a kit, and doing it. But for any given use case, like it depends, I guess. Does that satisfy your question at all?
Useful.
Yeah.
Thank you.
So yeah, I think the first step is to have an idea, and then the second step is to start reading about everything that you might need to know to interface with whatever your end result, your end product is. Yeah.
I think also if you don't have the protocol to access the air conditioner, like a power switch that you could just turn on and off is like a really easy hack to do there. I was just kind of interested in, to get started in this, like where do you order this stuff from and how much does it cost?
So I picked up this particular, we'll go back to here. I picked up the Android Edison on the SparkFun website. SparkFun is, they're trying to do the like the system on module microcontroller, get in that game. Lots of like build baby's first robot kind of kits, things like that. There, this all together cost me maybe $250. This chip, like I said, is defunct. There are still some out there in the wild, but they're not printing them anymore. So I wouldn't necessarily like make the choice of this one again, though I really do like the form factor. The NPX, which is I think the one that Google's giving away right after me. If you guys are in that one, they'll probably do a better job teaching about it than I just did. That one I think is a little bit cheaper than this, and it's like standard breakout board is a bit more something you'd be used to with like an Arduino or something like that, kind of like all-in-one kits. When I said cheaper, I meant the opposite of that, a little bit more expensive, because it's less modular. The accelerometer itself is like $4. The wires and stuff are pennies; they're nothing. So yeah, your big cost is the SOM, and then like whatever like prefab boards interface with it.
Okay, thank you.
Yeah. Thanks, guys. Thanks for being patient with me.